Hello there. We are going to discuss solution to all the questions those are asked in GATE 2008 with respect to analog circuit. These are the questions those are asked in GATE 2008 with respect to analog circuit. We will discuss solution to each and every question one by one. First question is question number 17. In question number 17, there is a circuit given with the combination of Zener diode and diode. Here input voltage is applied with sinusoidal voltage is applied whose amplitude is 10 volt, and it is given that the Zener diode has a breakdown voltage of 6.8 volt and each diode has drop of 0.7 volt when they are in forward bias condition. What we have to find out is what is the maximum and minimum value of the output voltage. So we will analyze what will be the output voltage by taking the positive half cycle of the input voltage as well as the negative half cycle of input voltage. Now during the positive half cycle, when the input voltage is varied from 0 to 6.8 plus 0.7 volt. Why 6.8 plus 0.7 volt? Because the Zener diode has a breakdown voltage of 6.8 volt. Once the input voltage is greater than this 6.8 volt plus this diode will have a drop of 0.7 volt. So the total voltage that is needed so that the diode will be in forward bias as well as the Zener diode will be in breakdown region is 6.8 plus 0.7, that is 7.5 volt. So when the input voltage is varied from 0 to 7.5 volt, what will happen? During that period, the voltage is not sufficient for the Zener diode to enter into breakdown region. So this will act as open circuit, and this is already, as it is in reverse bias condition, so this is already in open circuit, so output voltage will follow the input voltage. If we can draw the circuit during this span, that is V input voltage is varied from 0 to 7.5 volt, both the parallel branches will be acting as open circuit and the output voltage will follow the input voltage. Next, when the input voltage is greater than 7.5 volt, that is the input voltage can go maximum up to 10 volt. So when the input voltage is greater than 7.5 volt, then Zener diode will enter into breakdown region and D1 will be also forward bias. So now if we redraw the circuit, when the input voltage is greater than 7.5 volt, then the diode will be replaced with 0.7 volt battery as well as the Zener diode will be replaced with 6.8 volt battery. So the output voltage will be fixed at 7.5 volt. Now let's discuss the case what will happen during the negative half cycle. During the negative half cycle, this diode will be in reverse bias condition always. So this branch will be open circuited. And when the input voltage is less than 0.7 volt, up to that point D2 will also be in open circuit condition. So when the input voltage is varied from minus 0.7 volt to 0 or from 0 to minus 0.7 volt, then both the branches will be again open and the output voltage will follow the input voltage. But what will happen when the input voltage is negative and exceeds 0.7 volt? That is when the input voltage is less than minus 0.7 volt. In that case, this D2 will be forward biased. So the output voltage will see the voltage, that is a battery source which is of minus 0.7 volt. So output voltage will stick at minus 0.7 volt. Now we will try to draw the input voltage output waveform. Here is the input sinusoidal waveform which has a peak of 10 volt, and what will happen up to 7.5 volt the output voltage will follow the input voltage, and after 7.5 volt the output voltage will be fixed at that 7.5 volt. And during the negative half cycle, when the negative voltage is exceed minus 0.7 volt, then also the output will be fixed at minus 0.7 volt. If you draw the output waveform, then it will be clipped at 7.5 volt, that is 7.5 volt is the maximum voltage, and during the negative half cycle it will have the minimum voltage of minus 0.7 volt. So among the option, the correct option is option C. Thank you.